We think of comets as some of the heaven's more spectacular pieces of eye candy, and most are benign, orbiting harmlessly around the sun. But some will inevitably collide with another body, like Earth. At speeds of 25,000 miles an hour, even a small cosmic raider can wreak enormous havoc. But a larger object, over a mile or more in diameter, could cause devastation on a global scale.
An impact by a comet will kill so many people and can produce such long-term changes in the environment that it can be a complete catastrophe for all of humanity.
Scientists now believe a single blast from space helped wipe out the dinosaurs 65 million years ago. A comet or asteroid about 6 miles across slammed into Mexico's Yucatan Peninsula. It dug a crater nearly 50 miles wide and 20 miles deep in less than a second, and unleashed an explosion more powerful than all the world's nuclear weapons combined. The force of the shockwaves triggered earthquakes worldwide and sent tsunamis surging across the oceans. A mammoth dirt cloud erupted miles into the sky, engulfing the globe and blocking out the sun for years. The dinosaurs slowly perished, and they were not alone. More than half of the Earth's species were also wiped out. In our solar system, there are two kinds of cosmic bullets capable of devastation on a planetary scale: asteroids and comets. Asteroids are essentially tiny planets, dense boulders of rock and metal left over from the formation of our solar system 4.6 billion years ago. Most are bunched between Mars and Jupiter in an orbit called the asteroid belt. Comets, on the other hand, are far more mysterious. Though also formed at the birth of our solar system, they are made up of rock and ice. Many, like Halley's Comet, orbit the sun in predictable paths on predictable schedules. But there are countless others we know nothing about. They come hurtling out of the ether at unimaginable speeds of up to 100,000 miles per hour. For scientists peering into space, they look like lumps of charcoal on a black canvas, invisible until they are practically upon us. Only near the sun do comets become easier to detect. These icy bodies shed gas and dust as the sun warms them. When light hits the debris, they blaze into view and can be seen for millions of miles. But by that time, if one is headed for us, it may be too late to do anything to stop it. To date, more than 1,000 comets have been identified. Every year, we spot perhaps 100 comets we've never seen before entering the inner solar system. Each new arrival increases the odds that one will eventually strike the Earth.
The Earth is in a cosmic shooting gallery. We get hit by pieces of comets and asteroids of all sizes, and the big ones certainly pose a very real threat.
It's only a matter of time before the comet is in the same place as the Earth.
Giant pockmarks all over our planet testify to past assaults. And these collisions may be more frequent than we like to think. The latest big one happened a little more than a century ago. In 1908, a massive explosion rocked Tunguska in Russia's remote region of Siberia. Eyewitnesses described a flying star with a fiery tail. The sky opened and a fire brighter than the sun poured out. whether an asteroid or a comet. It collided with the Earth's dense atmosphere at such a high rate of speed, the friction caused it to explode in mid-air.
It blew up 5 miles above the surface of the Earth, creating this huge explosion, and lit up the atmosphere for days. You could actually read in Europe at night.
The Tunguska blast, as we now call it, was bigger and more powerful than the eruption of Mount St. Helens. It left no telltale crater, but it did flatten a forest of millions of trees over hundreds of square miles, an area bigger than that of Washington, D.C.
If that would have happened over a metropolitan area, it would have just wiped out the population for thousands of square kilometers around the impact site.
To astronomers, Tunguska was a near miss, a relatively minor impact. But a major impact from a comet would have devastating effects. Imagine the following scenario. Scientists have spotted a 2-mile-wide comet on a collision course with Earth. It's too late to stop it.
The first thing you'll know is when the sky lights up and the ground shakes.
Brilliant meteors streak across the sky as the giant comet's debris strikes the Earth's atmosphere. Forests catch fire, ignited by the superheated air. When the comet hits, the blast kicks up millions of tons of fiery rock and dirt. The airborne debris blankets the planet and blocks out the sun. Day turns to permanent night, bringing freezing temperatures and year-round winter. It takes more than a year for the dust to settle and sunlight to filter through the clouds. When it does, the Earth starts to warm. Quickly. Elevated levels of gases created by the fires turn the planet into a sweltering greenhouse. Millions of species of living things that survived the earlier cold cannot take the heat. They die. It takes thousands of years for life on Earth to recover. How great are the odds a comet will strike the Earth?
Will another impact occur? You bet. It's going to happen again. The Earth is sitting out there with a bullseye on it.
The chances of a major impact in our lifetimes may be slim, perhaps on the order of 1 in 100,000. But astronomers the world over are working fervently to understand these strangers in our midst, struggling to learn what comets are and where they come from. Mankind's ultimate survival may depend on our ability to stop one before it strikes. Donald Yeomans studied comets for NASA's Jet Propulsion Laboratory.
They're so big that they've got a lot of mass, and it's mass and velocity that's important when they hit.
If we could track comets in advance and plot their orbits, we'd likely have many years of warning if the orbits veered toward us. It may seem like a tall order to scan the vast sea of space for that one pinprick that could spell disaster. But that's exactly what astronomers are doing. In 1992, the U.S. government launched an aggressive program to analyze the threat comets and asteroids pose to Earth. It's called the Space Guard Survey. Today, scientists all over the world are involved in the painstaking process. They point their telescopes at a single region of the sky and take periodic snapshots. Then they line up the images, looking for anything that moves from frame to frame.
We are looking first for the larger asteroids and comets, the ones a mile or so in diameter, and eventually we'll extend it to the smaller ones.
Scientists have discovered nearly 4,000 comets in our solar system, with roughly 40 new ones in 2016. new comets are being discovered every year. We may never be able to locate every threat. There could be millions of comets and asteroids that measure 300 feet or so, the length of a sports field. Still, telescopes are a first line of defense against what could be a major disaster for our planet.
If you don't look, you won't know anything's coming. We would be taken by surprise just as much as the dinosaurs. If you do carry out a survey, then you hope that you can have warning. But it's one or the other. Either you have years or decades of warning, or you're taken completely by surprise. There's nothing in between.
There's three things that are important. You have to find them early, you have to find them early, and you have to find them early.
Suppose we do detect a comet headed for Earth. Then what can we do? Scientists have just started to come up with solutions. One of the leading ideas? Smash a rocket into it to slow it or knock it off course. That's harder than it may seem. In 2005, scientists were ready to test their theories about how a comet would react when it was hit by crashing a rocket into one. It was called Deep Impact. It began here at NASA's Vertical Gun Range in Mountain View, California, where it was the job of Dr. Pete Schultz and his team to figure out what the comet would do when it was hit.
This particular instrument allows us to fire a small sphere, about a quarter inch, at speeds that are maybe 6 or 7 times the speed of a rifle bullet. This whole assembly rotates up to an elevation where the gun is basically 3 stories high. This allows us to send the projectile through different openings in the chamber so that we can impact a flat surface at different angles.
Scientists believe comets vary in their makeup, so Schultz and his team built several different models, then hit each with a shot from their ultra-high-speed gun.
The first scenario is what happens if we impact into something that looks like lunar dust. The second one is what happens if we impact into fluff. And the third one is what happens if we impact into a fluff covered with an organic layer. As we go down and look at the evolution of this crater, we find at the very end, after it's finished, we can still see the crater here. But in these 2 cases, when we're using fluff, we can't see the crater. It's completely masked.
The fluff completely absorbed the projectile, a frustrating result for scientists hoping to get a look inside. And there was another possibility Schultz had to consider. What if the entire comet is extremely fragile and porous? He searched for a substance for that simulation.
The comet may be sort of like a fluff ball. It may have been very low density. What do we do to try to simulate that? The best thing probably is a complex organic. What would that be? Cotton candy. We've got our comet made of cotton candy. Let's turn off the lights and let's get out of here.
The projectile soars right through the comet, but the force shatters it.
Oh my God! There's no more comet, that's for sure. What a mess.
But this is not good news. A shattered comet can be even more dangerous than an intact one. The pieces remain on the same course, turning one projectile into many. But what does that mean for our planet if we're in the way? In 2005, the team at NASA had completed their tests and were ready to take the plunge. They would try to drive an 820-pound impactor into a comet to find out what's inside. Deep Impact Principal Investigator, Dr. Michael Ahern.
So here we have the model of both Deep Impact spacecraft. Many people think it was only one spacecraft, but it's really two.
January 12, 2005. After 6 years of study and preparation, Deep Impact is ready for liftoff.
3, 2, 1. We have ignition and liftoff of a Delta II rocket carrying Deep Impact.
The spacecraft's destination is a 4-mile-wide comet named Tempel 1. Discovered in 1867, it's well known to astronomers. It orbits the sun every 5.5 years and has lost much of its gas and ice.
People would argue that you should preserve the comets for posterity, but doing a violent study on one that is just typical of a whole class seemed to us to be the right choice for science.
Deep Impact takes 5 months to reach Tempel 1's orbit. On July 2nd, 2005, it turns and points its cameras at the comet, 500,000 miles away. Then, it releases its impactor. If all goes well, the collision will blow a hole in Tempel 1 about 600 feet across, 5 stories deep, about the size of the Roman Colosseum. But it might destroy the comet by breaking it apart, like cotton candy in the experiment. Back on Earth, hundreds of scientists hold their breath.
We lost signal, and we had to stand there and wait around. So everybody was trying to be, go keep busy and not feel anxious.
But just before impact, the signal returns. The half-mile-wide comet and NASA's 820-pound craft have glided at 23,000 miles an hour. The explosion is equal to nearly 5 tons of TNT. It completely vaporizes the impactor and kicks up far more dust than anyone expects. The amount of dust is a telltale clue to the comet's makeup. Tempel 1, at least on the surface, contains far less ice than scientists expected.
This is the first data we've ever had. So in that sense, it's revolutionary.
Analysis of the dust showed molecules containing carbon, organic material. So it's plausible that comets could have brought such material to Earth early in its history. Scientists hope to learn something else from Deep Impact. Clues about how to stop a comet from colliding with Earth. Some thought Deep Impact might knock Tempel 1 into a slightly different orbit. But the comet has continued on exactly the same path as before.
It was a secondary objective of the Deep Impact mission to come up with a plan to mitigate an impact if we had to.
Did we figure out what it would take to move a comet out of an orbit that was intersecting the Earth? We didn't figure out enough.
One plan calls for detonating a nuclear warhead near the comet to nudge it onto a different path. A controversial proposal because of the unknown consequences of releasing radiation in space. Others have called for drilling into the nucleus and setting off a blast inside. But as we've seen, this has the danger of turning one deadly projectile into many. The pieces could continue on the same orbit, and like the blast from a shotgun, wreak destruction over a wider area. Some have proposed less violent, yet equally intriguing solutions. They suggest putting lasers on the moon, where the Earth's atmosphere would not deflect them. The lasers could bore into a comet and melt its icy glue. We might even hitch a spacecraft to a comet and tow it out of our way. Whatever the solution, all ideas remain on the drawing board.
If a comet is on a collision course, we may not be able to do anything.
2004. The Cassini space probe approaches the ringed planet Saturn and its 56 moons. It discovers something almost unimaginable, conditions that might support life. And if those conditions could exist so close by, what might we find in the next galaxy? On a planet just like Earth. For millennia, we humans have looked to the skies and wondered whether we're alone in the universe. Today, we're closer than ever to knowing the answer. Some scientists believe we'll get our first look at our extraterrestrial cousins in the near future.
I hope it's in the next 10 years, and I'm ready for it next week. So, the sooner the better.
What's more, we could find these aliens not on distant planets in unexplored galaxies, but right next door in our own solar system. Scientists are now honing in on proof that ET is out there and living on the most hazardous of worlds. Our safari will journey to 7 destinations in our solar system to see just where these creatures could be and what they might look like. These exotic lands are unimaginably harsh. Life as we think of it would perish in an instant. But alien life may be far tougher than we expect, as we're learning from a surprising group of living things right here on Earth. Until just a few decades ago, we were sure our planet was unique. It is the only one we've found so far that has nurtured the evolution of millions of species. Thanks to its abundant sunshine, warm water, and protective atmosphere. We logically concluded that life needed each of those things, a conclusion that ruled out all other known worlds in our solar system. But then, biologists began combing some of the Earth's darkest and coldest places. And to their surprise, they found living, breathing creatures. Biologists call these organisms extremophiles. Some don't need light or oxygen. Others survive in tremendous atmospheric pressure. It seems life can turn up practically anywhere. Take Antarctica. After years of searching this arid, frozen landscape, scientists doubted they'd find anything alive. But in 1999, a team of explorers unearthed a rock from 6 feet under the ice. What they found amazed them. When they cracked the rock open, they found it teeming with tiny creatures. Here, at temperatures of 68 degrees below zero and 6 feet under solid ice, life had found a foothold.
Biologists have been increasingly discovering life, not kangaroos, but, simpler forms of life that live at very cold temperatures, very high temperatures, very great pressures, even in places where there's sort of a high degree of radiation. It turns out life is able to live in a much wider variety of environments on our own planet than we used to think.
And if life can survive extreme conditions, not just here at home, but elsewhere in our solar system, think of what this could mean.
unless there's something extraordinarily miraculous about our solar system or our planet, then life has got to be extremely commonplace. I mean, there's got to be large numbers of worlds with life, and some of them would have cooked up intelligent life.
In the beginning, our Earth was as deadly a planet as any. Over the first billion years of Earth's existence, cosmic debris pummeled it mercilessly. The impacts turned its surface into a broiling, seething inferno where life was impossible. But once the solar system settled down and the Earth began to cool, water appeared, setting the stage for life. In 1953, researcher Stanley Miller proved in a lab experiment just how easily life on Earth got its start. He combined water with hydrogen, methane, and ammonia, components of the Earth's early atmosphere. Then he zapped his solution with an electric charge to simulate lightning. His results shocked the world. Miller had created organic molecules called amino acids, the protein building blocks of all living things. If lightning helped jumpstart life on Earth, could it have done the same on other planets? Galactic probes have now found the ingredients in Miller's experiment throughout our solar system, including one essential to life.
One of the requirements that every form of life that we know about on Earth has, every single one, is liquid water. We've used evidence for liquid water to kind of guide our search for habitable environments.
Our safari is headed to 7 worlds, some possibly rich in water, where scientists believe aliens might be hiding. While any life there might have begun much like life on Earth, how it looks now is anyone's guess. We begin in the world that has always fired our imaginations, the planet right next door, Mars. Of all the planets where we've looked for life, it's the one we've studied most. The scientist who may get the first look at Martians, if they're found, is Steve Squires, principal investigator for NASA's Mars rovers.
Mars has always had, among all the planets, I think, a special fascination for humans. For a very long time, we've known enough about Mars to know that it is probably the most Earth-like.
It may be the most like Earth, with an atmosphere and seasons, but we humans would perish quickly on Mars. Its air is thin, 40 times thinner than the air at the top of Mount Everest. And it sits in a bad neighborhood of our solar system, near an asteroid belt. Its atmosphere is too flimsy to protect it. Asteroids continually bombard its surface. Violent winds can whip Mars's sandy soil into storms that consume the entire planet for weeks and spawn tornadoes 8 kilometers high. Midday temperatures at the equator of 1 degree Celsius fall to -70 at night. David Grinspoon is a curator of astrobiology at the Denver Museum of Nature and Science. As he sees it, Mars would be warmer if it wasn't a planetary runt.
When I grab coffee on a cold morning, I know that a small espresso is going to cool off quickly, whereas a larger coffee is going to stay warm much longer. Large objects stay warm longer because their interiors are shielded from the outside where the cooling occurs. And planets are exactly the same way. A small planet will cool off early in its history. A larger planet like Earth will stay warm for billions of years, which makes it a better place probably to look for life.
Despite Mars's drawbacks, it has always fascinated scientists because its terrain seemed to give evidence that it might support life. Its dynamic landscape of mountains, volcanoes, and deep ravines is not unlike our Earth. To early astronomers, these features look like oceans and rivers, and even a system of canals, supposedly not just supporting life, but actually produced by it.
Percival Lowell in the United States observed these things and inferred that, in fact, these things were so straight and so regular in geometry that they had to have been the product of intelligent life. Okay? Well, he was right. The problem was the life was at the wrong end of the telescope. In viewing this thing visually through a telescope eyepiece, the human eye-brain combination started to connect things that weren't really there.
Lowell was not alone. Some scientists were shocked when the probe Viking 1 beamed back this image. Is that a human face? Perhaps produced by Martians in their own likeness? Until recently, we've never really known where to look in our solar system for extraterrestrial life. But we've always known what the aliens would be like once we found them.
Consciousness. I was on a table.
Usually, there is more than a hint of the Earthling in our aliens. Hostile or lovable, they tend to resemble mutant images of ourselves. As a senior astronomer at the Search for Extraterrestrial Intelligence Institute in California, Seth Shostak has spent his career listening for the radio waves of a distant alien society.
There's no reason to assume that they're going to look like us or even think like us or behave like us or have language. You know, you just have to look at the variety of life on Earth and you see that, you know, nature can come up with lots of different forms.
But if there is life on Mars, how could it survive in such extreme conditions? Since the 1960s, scientists have sent dozens of probes to the Red Planet. The first pictures of the barren landscape quickly dashed any hope of finding intelligent beings. But what scientists did see startled them. Though there's no evidence of Martian-made canals, there are signs that Mars actually may have had water. Some think the angry red planet might once have been blue.
You just have to look back a couple of billion years, 3.5 billion, 4 billion years ago. Mars had a thicker atmosphere, had water on its surface clearly. Maybe it developed life. And as it slowly went bad, you know, the life had to adapt.
Life may have adapted, not died off, because some liquid water may still exist underground. But with no surface water, frigid temperatures, and ultra-thin atmosphere, Mars is a planet only one kind of creature could love, an extremophile. Extremophiles thrive in the cruelest of places. To see where they might lurk on Mars, we head to the Valles Marineris, a massive rift in Mars's surface, 20 times wider than the Grand Canyon in places, and almost as deep as Mount Everest is tall. Lakes may have once flooded this valley, and those lakes could have hosted life. As the water dried up, life could have evolved to cope with the harsher environment. We won't know what these extremophiles are like until we find them. But they may resemble creatures that exist in extreme places right here on Earth. An unusual team of biologists, called astrobiologists, study Earth for the kinds of life we may find in outer space. Astrobiologist Rocco Mancinelli is on the hunt for Mars's extremophiles.
If it went beneath the surface, and some of it undoubtedly did, then what happened to it? Well, it formed brine pockets. So what kind of organism can live in a salty brine? A salt-loving organism.
Astrobiologist Chris McKay thinks he knows the kind of salt-loving creatures that might survive on Mars. Creatures much like those he's found in one of the driest, saltiest places on Earth.
The fundamental challenge to life on Mars is, in a sense, the fundamental challenge of life here in Death Valley. It's dryness. That is the hardest thing for life to adapt to.
Thousands of years ago, a salty lake covered Death Valley, just as lakes filled Mars's Mariner Trench.
Move in closer. This is still wet, a little wet.
This appears like a lifeless place, a big, flat, white, empty horizon. But yet, just below the surface, we find layers of algae and bacteria growing. They're living in an environment that in many ways is fundamentally different from the environment that we sense on the surface. Here you're in a place which looks lifeless, looks dead, and yet you dig down and hidden underneath, there it is.
Beneath the salt is a layer of hardy green algae that survive on the water and light that trickle through. The algae in turn feed salt-loving microorganisms.
Here in deserts on Earth, dried, salty lake beds, we're going to find them on Mars as well.
Salty deserts are not the only places life might be hiding on the red planet. There are Mars's tremendous volcanoes, some of them 6 times larger than those on Earth. Astrobiologist Penny Boston studies the caves, called lava tubes, left over after volcanic lava has dissipated. Not long ago, we assumed caves like these were devoid of life. They get no sunlight, and no sunlight means no photosynthesis. But in lava tubes outside Albuquerque, New Mexico, Boston has found evidence of extreme life.
Because we know Mars has many, many lava tubes. And so here we have the opportunity to see how these formed and also to look at the life that inhabits them.
The extremophiles Boston has found appear to be thriving. They get their energy by feeding on the minerals in the cave wall.
So here we're up close to the wall, and you can see these white patches here growing against the black basalt. And each one of these is like a major city for these little guys. And they're all nestled in these little pockets in the basalt. And so these guys are permanently adapted to these freezing temperatures. They never see any light, and they get what they can find in the environment.
Are there creatures like these in the caves below Mars's volcano fields? Boston thinks so.
We are going to find life, and I just hope that I live a long and healthy life so that I can still be around to see that.
We may already have had our first glimpse of Martians, not from our visit to their planet, but from their visit to ours. 16 million years ago, an asteroid slammed into Mars and propelled a 2-kilogram rock into space. Amazingly, that rock sailed to Earth and came to rest in Antarctica. Inside, NASA scientist David McKay and Everett Gibson were amazed to spot the outlines of fossils. Water has carved small tunnels in the rock. And in these tunnels, McKay and Gibson found what they believed to be evidence of bacterial life.
These are little microbes, and they're dead, and they're fossils, or in some cases, we don't even see the forms. We see the footprints or the evidence that they were there.
Life from Mars? Maybe. The hunt is only just beginning. NASA plans to send a rover called Phoenix to Mars. It will study the planet's ice cap and probe 3 feet beneath the surface. NASA even has a plan to send human visitors. They may not meet the little green men of our imaginations, but they could encounter life in some form. What will it look like? it is likely to be a subterranean dweller with an ability to survive on little water. Perhaps an organism with a taste for minerals, like the creatures in the lava tubes of New Mexico. Even the smallest find would have enormous implications. Proof that life is not unique to Earth, but exists just next door. Our safari to the places in our solar system likely to harbor alien life now takes us past the asteroid belt on the far side of Mars. Here, Jupiter reigns. But this planet, the largest in our solar system, is fairly hostile to life, thanks to its toxic gases and overpowering gravity.
Not only is it pretty cold out at Jupiter, it's also, it's got this really thick atmosphere, tens of thousands of miles thick, and it's got ammonia and methane and, things used to clean the bathroom. But Jupiter has more than 60 moons that we know about.
At first glance, those moons would seem unlikely places to seek alien life. Their atmospheres are thin, and they are inhumanly cold. The temperature on Callisto is lower than -200 degrees Celsius. The scientific probes Voyager and Galileo have detected little on the surface of these moons but ice, with one dramatic exception. Io is one of the closest moons to Jupiter. When NASA sent Voyager 1 to Io in 1979, astronomers were astonished to find its surface roiling with giant volcanoes.
Io is the most volcanically active place in the solar system, just spewing volcanic material from its surface all the time.
What could be heating the interior of this frigid moon? Amazingly, it's the force of gravity from Jupiter. The giant planet exerts enormous gravitational pull on its moons. The closer the moon, the stronger the force. So strong, it can actually stretch their crusts. But some of these moons have elliptical orbits, so as they near Jupiter, the crust stretches towards it. When they move further away, the crust relaxes back towards spherical. This constant tidal movement creates friction deep inside, and that friction generates heat. It's like rubbing two sticks together to start a fire. The pull of Jupiter is heating Io from the inside out. Volcanic fumes and lack of water make Io inhospitable to life. But Jupiter's other large moons are more distant, close enough for Jupiter's gravity to warm them from within, but distant enough to remain calm on the surface. 3 of them look particularly promising as possible homes for alien life. The one furthest from the giant planet, Callisto. On its surface, Callisto looks like our moon, scarred and cratered by countless hits from asteroids. Those impacts may have melted the surface ice for brief periods, allowing life to take hold. But in 1998, the Galileo spacecraft detected a much more promising incubator deep beneath Callisto's surface. Radioactive rocks and tremendous pressure in its core generate heat inside Callisto. The heat may be melting its icy crust from below, creating a hidden ocean. And hidden oceans could mean hidden life. As we fly closer to Jupiter, we find its largest moon, Ganymede. Ganymede is also deeply scarred. Ridges rise above its surface. Those bright spots are craters as big as 5 kilometers across, and likely to be lined with frost. But these photos offer the most compelling clues to where life here might hide. They show flowing glaciers. Glaciers that resemble those on Earth. Ganymede's moving glaciers could also be signs of heat within. So, like Callisto, Ganymede could also have a hidden ocean, buried beneath as much as 190 kilometers of ice. The third moon on this leg of our alien safari is the most intriguing. It is called Europa, and of the three, it resides closest to Jupiter. That proximity to the giant planet means Europa's core may be very hot, far hotter than Callisto's or Ganymede's. But its surface remains frigid, a potent combination for life, since there could be a temperate zone where they meet. Mammoth fissures scar Europa's thick crust of ice, a sign that ice is always shifting. On our own planet, we see the same cracks in the ice sheets covering the Arctic Ocean. Europa's crust may be riding the largest ocean in the solar system, an ocean twice as large as all of Earth's put together.
Now those oceans, if they're there, and the chances are pretty good that at least some of them are, they've been sitting around for a long time, 4 billion years, a little longer, right? In 4 billion years, an ocean of water, do you think anything might have cooked up there? Well, it certainly seems plausible.
The environment in Europa's ocean is more or less as nice as the environment in our own ocean, as a place for living things to exist. Heck, things from planet Earth could probably live in the European Ocean.
But Europa's oceans will be very cold, even slushy. And sunlight never penetrates them, thanks to an icy cover that may be 16 kilometers thick. We might never have thought life could exist here, if not for a revolutionary discovery off the coast of Ecuador. Deep in the Pacific, biologists have found flourishing communities of tube worms, crabs, and even squid. These creatures are thriving despite complete darkness, extreme cold, and the pressure of the deep ocean. They feed on bacteria that take their energy not from the sun, but from chemicals erupting from the sea floor. We might find very similar volcanic vents on Europa, supporting their own web of life. To find out, NASA scientists would like to put a lander on the European surface. Some would like to send a cryobot, a robot that would melt the ice and release a probe into the liquid below.
That's not so hard to do. You just have to melt your way through. But you're going to have to melt your way through not a couple hundred feet, but maybe a dozen miles of ice. And send down a fishing line with maybe a video camera and a light bulb on it and look around.
In all that water, we can't rule out the possibility that very simple life forms have evolved further. We might even find creatures as advanced as some here at home. Most likely, however, we would find microbes. But even that would be a sea change in how we view the birth and growth of life. Europa was warm. What if the place is one of the coldest known? Or if its lakes flow with toxic chemicals instead of water? These are the worlds we find as our safari continues even deeper into space. As our safari in search of alien life sweeps by the ringed planet, Saturn, we can see the violently swirling gases that choke its atmosphere. We can also feel Saturn's gravity, weaker than Jupiter's, but still formidable. We'll keep moving. We're not likely to find living things here. Saturn's rings are also extremely inhospitable. They're made of rock and ice, as small as a grain of sugar or as big as a house. But Saturn has many moons, 56 that we've spotted so far. Our safari heads first to one of those moons, a tiny frigid satellite called Enceladus, just 500 kilometers in diameter. Here, gravity is very weak, a fraction of that on Earth. And Enceladus has hardly any atmosphere. It reflects back into space almost all the sunlight that hits it, making it the shiniest object in our solar system. Until very recently, we also thought Enceladus was too cold to support life. It appears we were wrong. In 2005, after a 7-year journey, the Cassini spacecraft approached the tiny moon and detected something that stunned the mission's principal investigator, Caroline Porco.
So this was the picture that just, you know, grabbed us. Just was shocking.
Those are plumes made of water from a geyser. The geyser's steam and hot water hit the cold vacuum of space and explode into a jet of ice. With little gravity to rein it in, the ice cloud can grow as big as Enceladus itself. Porco has never seen anything like it anywhere else.
It's like a planetary explorer's dream to come upon a body like Enceladus. Those jets, those fountains, if you will, just spewing vapor and icy snow hundreds of kilometers above the south pole of Enceladus.
There's only one conclusion. Tiny, frigid Enceladus is piping hot within. Like Jupiter, Saturn's giant gravitational field tugs on its satellites, creating friction and heat within.
As far as we can tell now, it seems like an inescapable conclusion that there may be liquid water deeper down on Enceladus because it's warm. And the best models we can put forth right now to even explain the warmth, much less the jets, seem to indicate that you would get temperatures warm enough to melt water.
Heat, liquid water, even the furthest reaches of our solar system may contain the chemistry for life. What kind of creature could live in the steamy waters of a geyser? Thanks to hot springs back on Earth, we have some idea. At one point, we assumed nothing lived in the steam-driven fountains of Yellowstone National Park. But then, biologists discovered microbes in these waters. Microbes that feed on chemicals dissolved in the water. Today, we call them thermophiles. The hardiest can thrive in boiling water. Could there be thermophiles on Enceladus? To find out, our safari takes us in for a close-up of this extraterrestrial Old Faithful. It's too cold for anything to live near the surface, but temperatures there are minus 165 degrees Celsius. But what about the hot water inside? In the ice plume above Enceladus, Cassini's probes have found carbon dioxide and methane, chemicals that could feed life below. Just as the chemical-laden springs of Yellowstone feed microbes living there.
We have a body that very, very likely has liquid water in its interior, has shown us already it's got simple organic compounds, and you know, a whole host of things that make it, I think, a major body of astrobiological interest in our solar system.
If Enceladus has been a shock, astronomers have been astounded by another of Saturn's moons, Titan. It may be the unlikeliest to harbor life. Titan gets only a limited amount of sunlight, about 1,000th as much as Earth. Probes sent to Titan have detected ice, but no liquid water. And at temperatures of minus 138 degrees Celsius, that ice is hard as stone. What could possibly make Titan a promising environment for alien life? Remarkably, Titan in many ways resembles the Earth, but not the one we know now.
Titan has turned out to be the body fantastic in the Saturn system, which is long suspected of having an environment at the surface, not only similar to the kind of environment we find here on Earth, even, believe it or not, similar to the kind of environment we had on Earth before the emergence of life.
Titan intrigued Carolyn and Porco's team so much, they directed the Cassini spacecraft to send a probe there in 2005. It was the most distant surface mission ever conducted. The probe saw just ridges and plains. But a later flyover by Cassini spotted a shoreline. Soon, thousands of lakes came into view, at least one bigger than the Great Lakes of North America. It's the first time we've ever detected liquid on the surface of another celestial body.
Kind of looks like Minnesota, except the lakes are not water. They're liquid natural gas. But liquid natural gas is a liquid.
And that's not snow. Those are methane flakes. Like Earth, Titan has weather. But it's of a rather psychedelic kind. There are even methane hurricanes.
It's not water, it's methane, doing all the exact same things. Raining, evaporating, flowing in rivers. So you have something that is basically doing what water does on Earth, on Titan, only it's methane.
A similar scene may have existed on Earth 4 billion years ago, making scientists suspect that Titan could also be an incubator for life.
Chemistry does go on. At those cold temperatures, it's really slow. But Titan has had 4 billion years in which to do some chemistry, and maybe in that period of time, maybe something is cooked up.
It would have to cook up without liquid water, something we've never seen before. But scientists aren't ruling it out. The substitute could be the methane, so abundant on Titan. Used for fuel on Earth, methane was long thought poisonous to all life. But in 1997, researchers examined mounds of methane ice in the Gulf of Mexico, and they were astonished to find colonies of small centipede-like worms thriving amid the frozen substance. They think the worms may eat bacteria that feed on the methane.
In general, things that we think of as deadly, many of them are potentially lively. If you can figure out an evolutionary way to tap into that energy rather than having it destroy you, then it can be bountiful.
There could be one more complication for life on the surface of Titan. With only a weak magnetic field to shield it, living things on the surface could be exposed to cosmic radiation. But that might not be a problem for an extremophile, as we found here on Earth. Biologists have uncovered plenty of life near Chernobyl's contaminated nuclear reactor. And even swimming in toxic radioactive spills, actually feeding off the decaying molecules. It's possible Titan's life forms could do the same. To find life on Titan, we may have to dive into its methane lakes, where we might find chemical-loving bacteria. We may even find microbes resistant to radiation, not unlike those here on Earth at Chernobyl, living on its rock-hard ice sheets. Organisms that eat methane might give off heat, melting the ice, possibly creating another fountain for life. There's no doubt, life on Titan would be a strange brew. But we have yet to visit the most bizarre world where scientists believe life could exist, and it's much closer to home. Our safari of the world's most likely to harbor alien life has taken us far. We've visited frigid deserts, submerged oceans, and methane lakes. But the world we are about to visit may be the most extreme of all. For our final stop, we are turning back toward Earth, to Venus. our closest planetary neighbor in the solar system. If life can survive here, it seems it could exist almost everywhere. To reach the surface of Venus, we have to fly through a dense layer of yellow clouds, 64 kilometers deep, with a composition similar to battery acid. The atmosphere here is 90 times heavier than Earth's, too heavy for a human to tolerate. On the ground, there are extinct volcanoes and lava flows as far as the eye can see. They cover 85% of the planet's surface. It is hard to believe Venus once had vast oceans.
You basically had a runaway greenhouse effect where as it starts to get warmer, the oceans start to evaporate, and then that puts water vapor in the air. Well, water vapor is a potent greenhouse gas, so that's what leads to the runaway. The oceans basically boil off, and then the CO2 all ends up in the atmosphere, and so today you have this very hot, hyper greenhouse planet.
With temperatures around 460 degrees Celsius, Venus is even hotter than Mercury, the planet closest to the Sun. Not a surface hospitable to life.
Life as we know it cannot exist on the surface of Venus because organic molecules would just be ripped to shreds by the hot gases.
But we've stopped here, not because of what's on the ground, but what's in the air. In 1982, the Soviet spacecraft Venera 14 visited Venus. In the clouds, 50 kilometers up, it detected temperatures much cooler than on the surface. What's more, it found the molecules so critical for life, H2O. So far, every bit of water we've found beyond Earth is frozen solid. Only in the clouds above Venus have we found it in vapor form, a possible incubator for life. But Venus's clouds are also filled with highly acidic sulfur. Once, we thought nothing could live in sulfur. But scientists have analyzed some of the most acidic water on Earth, leaching from a California mine. In sulfuric acid strong enough to erode metal, eat through clothing, and dissolve human flesh, they found life. Acid-loving extremophiles. These organisms feed on sulfur compounds, like iron sulfide, eating the iron and emitting the highly acidic sulfur. Do extremophiles like these float above Venus? Astrobiologist David Grinspoon likes to think it's possible.
Maybe in the clouds of Venus there are some sulfur-based organisms. Sulfur actually absorbs ultraviolet light in interesting ways, and I'm just imagining that there's maybe some kind of photochemical reaction going on where ultraviolet light is actually being used to convert chemicals into some higher energy state, which then is basically being eaten.
What will these aliens be like if we do find them? They would have to tolerate high temperatures and enormous atmospheric pressure. They would also need to thrive in acid concentrations deadly to most life forms. Perhaps they might resemble a hardier version of the acid-resistant extremophiles in California's mine.
We keep finding that life lives in places that we used to think were inhospitable. So whenever we say, oh, it's impossible, you couldn't have life in the clouds of Venus, I think we have to be very careful because they might just reflect our own ignorance or our limitations on our own imagination, and maybe not real limitations on the ultimate creativity of nature, which seems to find solutions to these problems.
As our safari returns to the cool, blue, lush and lively world of Earth, we can see why we so revere its life-sustaining gifts. But, as we are learning, even the most extreme environments can harbor living things. Extremophiles may resemble the first version of life in our universe, and they could even be the most common. Could they have evolved further from these humble beginnings? Could intelligent life be out there as well? For more than 40 years, scientists at the Search for Extraterrestrial Intelligence Institute in California have been searching the skies for answers to that question. Astronomer Seth Shostak believes he'll know the sound of alien life when he hears it.
We have a couple of observing projects to try and find signals. The biggest one are our radio searches, and that's where we use big arrays of antennas, and we point these antennas at nearby star systems that we think, well, this is the kind of star that might have a planet that might be something like Earth. We point in those directions, hoping to pick up a signal that would tell us that somebody there is clever enough to build a radio transmitter.
It's a safari that never leaves home. Astronomers have also recently captured enough light from planets in distant solar systems to deduce their chemical makeup. They have found elements that may help form RNA, one of the building blocks of life here on Earth. And 20 light-years away, in the constellation Libra, a team of European astronomers has found a planet that could be warm enough to have liquid water on its surface, just like Earth. Meanwhile, headed to the furthest reaches of our galaxy are 4 spacecraft launched in the 1970s. Aboard 2 of them is a map of our solar system and the image of a man and a woman. 2 others carry a sample of uranium, whose rate of decay would date the probe, regardless of language. The 2 are also carrying what could be the most universal message of all, a recording that includes a composition by Bach. Just don't expect news anytime soon. These intergalactic postcards from the Earth will take 80,000 years to reach the nearest star. Our search for life beyond Earth has only just begun. There are billions of planets yet to be explored. Every one of them holds the tantalizing possibility of life. Even intelligent life.
Just in the face of this enormity, the idea that we're the only game in town, it just doesn't seem reasonable.
I think the question of whether we're alone is profoundly important for human beings in general. If you're aware, you really have to ask that question.
Somewhere in a galaxy, known or unknown, something or someone could be looking out into space, peering at the Milky Way and wondering, is there life out there?
The sun. For centuries, we humans have gazed at our neighbor and imagined an alien world. And as human technology advanced and telescopes brought it closer, we began to see signs of life.
As the 20th century began, mainstream credentialed astronomers were looking at Mars, thinking that they saw evidence for a society, a civilization on the red planet.
We Earthlings braced for contact. If there was life on Mars, what form would it take? We set off into space to find out. But as we approached the red planet, we discovered a new mystery.
All the elements needed for life are there. So what happened? Where did everybody go?
Mars is almost Shakespearean, a beguiling world. It's tricking us every way.
So Mars, dead or alive? Some think Mars was home to an ancient civilization.
There was at one time intelligent life on Mars, and they built something.
But the evidence continues to elude us.
If there's life there, we'll find it.
Across the globe, the race is on for the greatest discovery of all. Join skeptics and believers alike as we try to answer the age-old question, is there life on Mars? If If you're planning a trip to the planet Mars, here are a few travel tips to help make your journey as comfortable and rewarding as possible. All in all, the expedition will take about 2.5 years, including approximately 12 months aboard your interplanetary spaceship. So make yourself comfortable. Plan your provisions carefully. You'll need to bring plenty of water. At this time, there's no liquid H2O anywhere on the planet's surface. You'll also need an effective spacesuit and a sufficient supply of breathable air. Finally, remember, Mars is about 1.5 times further from the Sun than Earth, which makes this a cold world. The temperature can drop to a chilly minus 130 degrees Fahrenheit. So dress warmly. These technical issues aside, Mars has a lot to offer. It is home to the largest known volcano in our solar system, a magnificent Grand Canyon, and breathtaking deserts. For those of you interested in culture, a visit to the notorious Face is a must. We know you have a choice, so thank you for choosing the planet Mars. All in all, without ever setting foot on Mars, we know a lot about this distant world. But what we don't know is, what about life? When the first astronauts arrive on Mars, who or what will they find? Will aliens be there to greet us? Or is no one there at all? Inquiring minds want to know, is there life on Mars? It's a big question, and a fundamental one, because really, it's synonymous with the question of, are we alone in the universe?
If we go to Mars and find evidence that there was life on Mars or is life on Mars, then we'd be able to say that in our own solar system, life appeared twice. And I think that would be convincing evidence that the universe is full of life.
Discovering life on Mars could also reveal a lot about our own existence.
We have one kind of life adapted to one planet, even with all of its diversity. So looking at the way other planets may have given rise to a phenomenon that we would recognize as life can enable us to understand our own kind of life in a deep and fundamental way.
The stakes are high in the game of life, and Mars may hold the key.
If we're going to find proof of life on Mars, we're going to have to go to Mars to get it.
But getting to Mars isn't exactly easy. The Apollo astronauts took about 2 days to get to the moon. A journey to Mars one way is roughly 7 months. Mars takes about twice as long to orbit the Sun as Earth. So a space mission has to plan departure when the two planets are close. The challenge of bringing a mission back is incalculable in complexity. Just one of the reasons no manned mission has ever been attempted. But that's exactly what Dr. Robert Zubrin of the Mars Society wants to do. Bob Zubrin, an astronautical engineer with 15 years of experience in the space industry, has been planning a trip to Mars for the last 2 decades, and he's come up with a novel way to do it.
If we want to go to Mars, we need to travel light, live off the land.
What makes a Mars mission so prohibitively expensive is the amount of mass, mostly rocket propellant, you have to send there and back. Instead, Dr. Zubrin came up with the following plan. Take supplies enough to get there, then make what you need on the planet.
There's 3 things we want to make on Mars. First, most importantly, propellant. After that, water. And third, oxygen. We can make all 3 with this machine.
Here's how the machine works.
The Martian atmosphere is 95% carbon dioxide gas. We pump that into the reactor. We mix that with a little bit of hydrogen. You can make that reaction produce either methane or carbon monoxide or any mixture of the two. And water.
The methane and carbon monoxide mixtures can be used as rocket propellants for the return trip to Earth.
The water, we could keep the water and drink it, or we could electrolyze it into hydrogen and oxygen. The oxygen that comes off, we could use as breathing oxygen, we could use as rocket-propelled oxygen. That's how the machine works. It makes your fuel, it makes your oxygen, it makes your water.
And leaves enough room on your spaceship for food. All in all, it looks simple enough, and it's not just theory. Working with simulated Martian air, Zubrin has spent years testing and refining the technology.
This is a subscale methane carbon monoxide, oxygen rocket engine. It all works. It works great. These are great propellants. We start them right up with a spark plug time after time.
In a way, Zubrin has done all this to make a point. Current thinking is that it is too expensive and dangerous to send a manned mission to Mars. Instead, the international space community has deployed a range of unmanned robotic explorers on and around the planet. But Zubrin points out using robots to do field research leaves a lot to be desired.
Okay, we can send robots to Mars, and I support sending robots to Mars. I think we ought to send a lot more robots to Mars. Okay, robots can make all kinds of discoveries. They can give us all kinds of data. They can image the surface of the planet and possibly identify interesting targets for exploration. But they won't tell us the answers that we need to know. They won't tell us if there's life on Mars.
So does Zubrin expect to find life on the red planet?
I think that a naturalistic view of the universe would suggest that the Earth is not special, and that if life can evolve here, it could evolve elsewhere where environmental conditions are similar. And if there's life there, we'll find it.
But perhaps there's an easier way to find out. The answer could already be here on Earth. Every year, hundreds, maybe thousands of aliens come to our planet. Most arrive quietly and go unnoticed. Others enter the atmosphere in a blaze of glory. These aliens are meteorites. For centuries, these rocks from the sky were treated as curiosities, often ending up in local museums or private collections. But the information meteorites contain is so valuable that today, the scientific community sends out search parties to gather them. Although meteorites fall randomly all over the Earth, one of the most popular hunting grounds is Antarctica. Every year, scores of scientists take their lives in their hands and head to the frozen continent. The teams conduct a systematic grid search of the icy landscape, looking for telltale dark shapes against the blue-white of the ice. It was on an expedition such as this that a meteorite was found that would shake the scientific community to the core. The team sent it to a special facility at the Johnson Space Center in Houston, because this is where NASA keeps the aliens. 84001, or the Allen Hills meteorite. The strange green rock was kept under strict quarantine. It was processed, examined, and rigorously interrogated for information about its home world. It took 10 years, but investigators finally got the truth. This rock was from Mars, and it had a secret to tell.
Today, Rock 84001 speaks to us across all those billions of years and millions of miles. It speaks of the possibility of life.
So what was it the rock told us? We'll come back to that a little later. But perhaps the best evidence of life on Mars is not hidden deep in an alien rock. There are some who believe a vital clue is staring us right in the face. Richard Hoagland has dedicated his life to examining imagery transmitted to Earth from various Mars orbiters. Surveillance systems that have circled the red planet for over 30 years now. In the first pictures that the 1976 Viking orbiters sent back from the planet's surface, Hoagland saw something that blew his mind.
I looked at this and it was like, oh my God. This thing had symmetry, it had proportion, it looked like a statue.
Hoagland is referring to this remarkable image. A face-like structure the size of multiple city blocks. And Hoagland thought he saw more. Other structures surrounding the icon, eroded by time. To him, it looked like the ruins of a monumental city.
It looked eerily like an aerial photograph taken flying over Giza, looking down at the pyramids on the Giza Plateau. It looked like a ceremonial complex built by somebody with a huge sphinx-like creature staring up into space from the sands of Mars at the telescope orbiting 1,000 miles overhead. Somebody was down there, and they cared enough to leave the very best.
Needless to say, Hoagland's theory raises more than a few eyebrows. But did life on Mars ever exist? Was there once an ancient civilization of alien life forms? And if so, where did they go? Believe it or not, the idea that Mars was occupied by a race of intelligent extraterrestrials was not the creation of science fiction, but science fact. In the early days of humankind, Mars burned faintly red in the night sky, leading some to equate it with a mighty god, naturally, the god of war. But then astrologers, using a new contraption called the telescope, determined that those lights in the sky might be planets, much like ours. This meant there might be other civilizations, other life forms out there. And Mars was about to become the star attraction. Thanks to Italian astronomer Giovanni Schiaparelli. In 1877, Schiaparelli trained his telescope on the Martian surface and observed the existence of canali. By this, he meant natural channels. But due to an unfortunate translation, these channels became canals, which implied a man-made phenomenon. To fully understand the impact of this, consider that only a few years earlier, human engineers had completed the awe-inspiring Suez Canal. It defied nature and geography by linking the Mediterranean and Red Seas. It was considered the latest wonder of the modern world. Whether or not Schiaparelli believed the canals to be made or natural, the word itself sparked the public imagination. If there were canals on Mars big enough to see from Earth, really intelligent beings must have built them. The rumor was dramatically compounded by an American astronomer named Percival Lowell. Lowell was a highly respected man of good society who had a profound love of astronomy. He developed a fascination with the canals of Mars and sat up through the nights observing the red planet. And what Lowell thought he saw in the wee hours was a dying world crisscrossed by constructed waterways. Perhaps, he wrote, creatures short on water have built an irrigation system that circled the planet. By the turn of the 20th century, the idea that Mars was occupied had hit the mainstream media. New York Times headline, 1911. Martians build 2 immense canals in 2 years. Martian civilization was usually perceived as being ahead of us in evolution. And each earthbound nation projected onto Martian society the diverse vision and fears of its own future. In this 1924 movie from Russia, Mars is portrayed as going through a proletariat revolution and ending up successfully communist. But many thought that Mars was dying, and some said it was only a matter of time before Martians tried to contact us. And so, some thought, they did. Through another new technology.
This is Seth Shostak. Go ahead, caller.
Radio. Astronomer Seth Shostak takes up the story.
It goes right back to those early radio pioneers, and none so directly as to Nikola Tesla.
One of the most brilliant electrical engineers of all time, Nikola Tesla, was the first to claim someone from beyond this planet was trying to get our attention. In 1899, Tesla was experimenting with an electric invention that essentially acted as a large antenna when he noted something strange. Repetitive signals which were substantially different from the signals he had noted from storms and earth noise.
And it's only natural to imagine that he would ascribe this to some sort of intelligent beings, because as far as Tesla knew, only transmitters could make radio sounds. So he naturally assumed that if he heard something, somebody was broadcasting it.
In fact, Tesla was probably mistaken, as Shostak often gets to explain on his weekly SETI radio show.
Well, we don't know for sure what Tesla heard, but most likely it was something that we call whistlers. These are just distant thunderstorms, lightning discharges that produce natural radio waves that get distorted by the atmosphere as they propagate around the Earth and make a sound that kind of sounds like a whistle.
Modern science may have an explanation, but in a way, Tesla was ahead of his time. The idea that you could send signals from one planet to another made sense and inspired subsequent radio enthusiasts to listen for signals from outer space.
A guy by the name of David Todd realized that in 1924 there was a real opportunity to listen for the Martians. And the reason was that in 1924 you once again had one of those circumstances where Mars and the Earth got close to one another. So he organized an effort to get people to stop transmitting for 5 minutes every couple of hours so that people with the right equipment could actually listen, and this included the military, to listen for signals that might be coming from Mars or some other planet.
But whatever the message might have been, it seems we humans didn't get it. At which point, the Martians turned nasty.
Ladies and gentlemen, we interrupt our program of dance music to bring you a special bulletin from the Intercontinental Radio News.
In 1938, Mars attacked. Turns out it was apocryphal, an imaginative radio play based on the H.G. Wells book, War of the Worlds. But many believed it and thought Earth was under imminent threat from aliens.
Now, mind you, it wasn't so unreasonable. I mean, there were places that really were being invaded at the end of the 1930s, after all. So the mindset of the public was kind of attuned to the idea of hostile forces coming in and taking over.
And sure enough, they came. Martians, great and small, came out of the skies and landed in our movie theaters. Sometimes they looked like giant insects. Mostly they seemed suspiciously human-like, and they came in a bewildering variety of shapes and sizes. They had laser guns, evaporators, death rays, and deadly kisses. They wanted gold, weapons, earth women, and human blood. One thing's for sure, they were very rarely friendly. Next thing you know, real flying saucers were being reported from San Fran to Timbuktu, and the phenomenon of alien abductions was born. The world, it seemed, had gone crazy for extraterrestrials. For all its downside, the popular imagination paved the way for mankind to make that giant leap. In 8 years, the U.S. built a transport system and became a spacefaring people. Perhaps we were determined to bring democracy to the communists on Mars. In fact, we only got as far as the moon. And while there were no aliens up there, you might argue that if we could make the trip, then extraterrestrial life, capable of interplanetary flight, was at least a possibility. So what about Mars? As our technology got better, we sent a robotic scout to the red planet. The landing was a success. The robot touched down, turned on the camera, and we finally got a good look at Mars. It wasn't what we expected.
How disappointing after centuries of assumption that Mars was inhabited, that it had cities, it had canals, and the reality was that it was just this terrible, awful, dead-looking place.
Ladies and gentlemen, we regret to inform you, Mars is dead. Or is it? Mars may be unoccupied now, but if we're to believe Richard Hoagland, the red planet once hosted a magnificent civilization. Hoagland is the principal investigator of the Enterprise mission, a loose collection of scientists, researchers, and Mars enthusiasts. They've spent years trying to prove this extraordinary theory. For Hoagland, it boils down to this.
If I had one catchphrase to describe the whole problem of convincing scientists that there is really an ancient civilization on Mars, it would be, it's the geometry.
Take the face-like structure from this 1976 Viking orbiter image. NASA claims it's a naturally occurring rock formation. Richard Hoagland thinks there's more to it.
If you actually look at proportions, where the mouth is, where the nose is, where the eyes are, they conform to commonly accepted statues and representations of human forms that go back literally thousands of years.
And Hoagland has found what he believes to be a highly complex geometric relationship between various structures centered around the face. Hoagland claims that the layout of this region, named Cydonia, is similar to what we see in ancient ceremonial complexes on Earth.
There are alignments, there's parallelisms, there's right-angle rectilinearity. They also appear to have a specific geometric relationship to the face, to another massive structure down here, to other structures.
To prove his theory, Hoagland and his colleagues have applied a series of computer image analysis programs, looking for, well, basically things that don't match the surrounding landscape. And the face and a couple of other structures register as anomalies, implying, he says, artificial constructions.
This is the real image, and this is the fractal representation. And again, it's the signal strength is basically...
Strictly speaking, a computer will find whatever you program it to look for. It doesn't actually determine whether or not the artifact is natural. But Hoagland claims there are some things you can see for yourself. Take this pyramid, an apparently perfect tetrahedral form with an accurate apex and sharp angles.
This unquestionably had to be made by someone because nature does not produce this kind of structure. If we were to land someday, find the entrances to this thing, walk inside, because if the exterior is preserved in this extraordinarily pristine form, imagine what waits us on the inside.
But if there was a civilization, what happened?
That's where things get interesting, but that's where we obviously cross the line from science to speculation. We have no ground truth, unfortunately.
So why isn't NASA all over this? Hoagland thinks the government is hiding something.
I believe there's a cover-up. Call it a conspiracy if you will, except they're not called conspiracies, they're called policies.
And why? Well, according to Hoagland, it goes back to an obscure Brookings Institution study commissioned by NASA and published in 1960.
There is a section devoted to the implications of NASA's discovery of extraterrestrial life. And the document recommended that if we were to discover, i.e. NASA were to discover evidence of extraterrestrials, that it should be basically kept secret because it had the potential at the limit to destroy civilization.
The argument seems to be that where a civilization comes into contact with one more technologically advanced, that civilization's in trouble. So does this mean the government is covering up aliens to prevent a societal meltdown? It's a bit of a stretch when you consider that all the Brookings report actually suggested was that we should do more studies. Hardly sinister stuff. Seth Shostak thinks there's a fundamental flaw in Hoagland's cover-up theory.
Well, doggone it, if the aliens are really here and they're really advanced and they're really malevolent, as they could conceivably be, then it really doesn't matter what the government does it? This is Bambi meets Godzilla, and Godzilla's going to win.
This from someone who believes there's life beyond Earth. Shostak works for an organization that operates on the assumption that not only is there life out there, some of it has technology. This is the Allen Telescope Array, built and operated by the University of California at Berkeley and the SETI Institute. SETI stands for the Search for Extraterrestrial Intelligence. It may seem out there, but SETI is an entirely scientific operation, manned by astrophysicists, engineers, and planetary scientists. Their objective is simple.
It's really easy to send signals between the stars. That's the bottom line fact. There might be thousands, millions, or more societies that are sending information from one star system to the other. Why not look for them?
SETI is essentially eavesdropping on the universe in an attempt to pick up a signal from outer space. To do this, SETI uses highly sensitive radio receivers that scan systematically through the billions of star systems in our universe. It's like scanning through your car radio dial as you travel cross-country, but on a cosmic scale.
Now, what kind of signal are we looking for? We don't care. Looking for the message requires a different kind of technology that we haven't built and won't build until we find that they're on the air. We're just looking for a signal that tells us, hey, their transmitter switch is on.
It may seem like looking for a needle in a haystack, but astronomy has made enormous progress in identifying the stars and planets beyond our solar system, which, combined with ever-improving technology, allows SETI to search with more precision. The motive, however, is as old as mankind itself.
We're trying to look for something that would show that You know, we're part of a bigger picture. We're not just a little bit of chemistry run amok on this small little world tucked away in the corner of a nondescript galaxy in an enormous universe.
So the million-dollar question, of course, has SETI made contact?
In 1997, we picked up a signal using the telescope in West Virginia that looked like the real thing. And we got quite excited, to the point where everybody was glued around the computer monitors just looking at what was going on.
The signal had all the qualities SETI looks for in an alien contact. It occurred on a very narrow frequency. This is key because while nature produces radio waves aplenty, they are like broad static across the dial. This one was emanating from a specific location in the cosmos. Throughout the night, scientists were on the edge of their seats trying to pin down the source.
I realized that the world from that day forward will really not be the same. I was very nervous, actually, because I didn't know what the consequences were going to be.
It took 3 days, but the engineers and scientists finally identified the signal, and it wasn't alien.
As it turned out, the signal was due to a European research satellite, the SOHO satellite, the signal of which had just gotten into the structure of our antenna. And that was a bit disappointing.
In conclusion, then, the industry experts, SETI, have not yet found any evidence of extraterrestrial intelligence.
As of now, one thing you can say, and that is we have not conclusively proven the existence of any life, intelligent or not intelligent, beyond the bounds of Earth.
And what about Mars? Martian monuments aside, you'd be forgiven for thinking that 30 years of remote observation has done nothing but confirm our nearest neighbor is dead. But in fact, life on Mars has begun to make a comeback. It's all about water. When NASA scientist Chris McKay saw those 1976 Viking images of a dry, barren Mars, he was intrigued.
I remember the overwhelming impression I got was, the lights are on, but nobody's home.
What McKay is referring to is what he poetically calls the ghost of water past. He's offered to meet us in the Mojave Desert to explain.
There's no water in this lake bed now, but the geology, the surface of the ground, shows evidence that there was water here. And that's what we see on Mars. We see dry lake beds. We see river beds that have no water in them, but clearly did at one time. And this is the evidence that Mars had water. And it's that water that's of interest to us from a biological point of view.
Although, in fact, the Mojave gets a whopping 5 inches of rainfall every year, Dr. McKay uses this desert as a near waterless zone to conduct experiments relevant to his theory about Mars. And life, it seems, can thrive nicely in these conditions.
We find microscopic life, microscopic algae, that have learned to survive under dry conditions. This organism, this algae, is the dry version of pond scum. They wait out in the dry for months, maybe years, and then a rain comes and they very quickly set up shop and do their biological thing, and then it gets dry and they shut down and wait again.
Dr. McKay certainly isn't claiming that Mars is populated by desert algae, but he thinks the odds are in favor of past life.
If we were to imagine what would the last Martian have been like as Mars went from a fairly wet, Earth-like environment to the dry desert that it is today, it would have been probably an organism like this.
Microbes? So much for the Martian monsters of the silver screen. But microbes bring us full circle. The fact is, some scientists believe we've already found life on Mars. And it's all because of mysterious clues in a Martian meteorite. Turns out our favorite Martian may be more like our favorite microbe. The 1976 Viking mission to Mars was a triumph of modern space exploration. But one unexpected bonus was information that could be used to further study our alien visitors. The unidentified meteorites sitting in cold storage on Earth.
Well, we've had meteorites we've known were meteorites for 100 years, but we didn't know they came from Mars until Viking landed and measured the gases in the atmosphere, and scientists studied the gases in these meteorites and showed that they were the same.
But how does a Martian rock get to Earth? Scientists think that some explosion, probably caused by the impact of an asteroid hitting Mars, blasts a rock off the planet and into space. It then hurtles around our solar system until, if it's very lucky, it gets caught by the gravity of our blue-green planet and plunges to Earth. Imagine the odds. For NASA scientist Dr. Everett Gibson, this event began a remarkable voyage of discovery.
For one to have life, you have to have the presence of water, you have to have the presence of carbon, you have to have an energy source, and you have to have geological processes. All of these four fundamental things are seen within the Martian meteorites. So, the conditions could be right for life to exist on Mars, perhaps in the past.
And it seemed the NASA team was about to prove it. Thanks to that odd little meteorite, 84001, from Mars.
600 million years after this rock was formed in the crust of Mars, you get water percolating through the rocks, saturated in carbon dioxide from the Martian atmosphere. As the water basically evaporates away, it potentially leaves the carbonate behind.
So the meteorite confirmed that Mars had once been wet. But there's more.
The carbonates contain organic matter. The carbonates contained an iron oxide mineral, magnetite.
Here on Earth, magnetite, essentially magnetic crystals, are often produced by microscopic life forms. This was getting exciting. Using the most powerful microscope at their disposal, the investigators now looked even closer and got the surprise of their careers. They saw what looked like minute worm-shaped structures. Quietly elated, the scientists were cautious.
We said one explanation could have been biology operating. Could have been the signatures of something like a life process.
So was this finally confirmation of life on Mars? Well, from the moment they were announced, the microbes have been controversial. Critics say that the carbonates, organic matter, and magnetite crystals can be explained through other non-life processes, and many believe that the worm-like structures are actually clumps of a coating material used to examine the sample in the laboratory. Still, others point out that the rock could have been contaminated at any time, perhaps when it was lying around for thousands of years here on Earth. Nevertheless, the possibility of ancient Martian bacteria raised the ante on life on Mars. If once upon a time Mars was warmer and wetter and had some early form of microbial life, did it survive, thrive, and grow up to build like an Egyptian? Well, it's a nice idea, but seems unlikely when you consider that conditions on Mars are dry, radioactive, and extremely cold. How could anything survive in this hostile environment? But we could be underestimating the nature of life itself. Microbial life, that is. Believe it or not, astrobiologist Penny Boston is searching for life on Mars by dropping deep into this heart of darkness. This is a lava tube, a subterranean cave formed by underground lava flows during volcanic eruptions that occurred thousands of years ago. And Boston has someone she wants us to meet.
Sometimes they're in crevices, sometimes they're kind of hard to see.
Is this when the scary monster reveals itself?
Ah, there's one.
Actually, no. This is an extremophile.
We're looking for what we astrobiologists call extremophiles in this environment, and that means that they're organisms that are living in very difficult conditions. In this particular case, these organisms are living in a very cold cave right around freezing. They are making their living without benefit of sunlight, and there's almost nothing to eat in this cave.
In recent years, scientists have discovered tenacious microorganisms living in all forms of extreme environments. So if on Earth, why not on Mars?
We think that Mars is covered with lava tubes. We believe that by looking at organisms that live in these extreme circumstances on Earth, we can learn a lot about what to look for on Mars, and that similar Martian organisms may be able to persist on Mars in places very similar to this lava tube.
To find out, Dr. Boston has created her own little Mars environment biospheres. essentially exposing a range of microscopic Earth life forms to various elements to be expected on Mars.
They have been subjected to Mars-like levels of high ultraviolet radiation and Mars-like temperature cycles. We have given them atmospheric compositions from very low levels of carbon dioxide with nothing else to perhaps 1/10 the density of Earth's atmosphere and tested them under those conditions.
And so far, she's isolated 36 different strains of organism that thrive quite happily. So in theory at least, life could survive the harsh conditions of Mars, except for one problem.
There's one thing for sure that we know, and that is that all forms of life on our planet require liquid water. We don't know if that's going to be true on other planets, but we think that where there's going to be life, there's going to have to be water.
This simple fact has helped scientists in the 21st century refine the search for life on Mars into a comprehensive strategy. Dr. Jim Garvin is chief scientist at Goddard Space Center and a veteran of NASA's Mars exploration program.
NASA uses a term, follow the water. Following the history and record and abundance and inventory of water is a wonderful way to search for something as tough, perhaps elusive, as life.
We already know that Mars was wet in its ancient past and has reservoirs of ice in the polar caps. But using remote sensing technology, NASA has found what could be evidence of a modern water cycle.
We've discovered tens of thousands of hillside gullies that clearly released a fluid, likely liquid water, in the extremely recent geological past.
They've also discovered that Mars has a vast underground reservoir of ice, spanning about 30% of the planet.
The reservoir of water under the surface may include liquid zones. They may be liquid under the ice caps, they may be liquid hundreds of meters deep, they may be liquid tens of meters deep. All that points to a modern liquid water cycle on Mars.
Where there's water, there could be life. And when it comes to the question of life, Dr. Garvin is a believer.
Absence of life in all senses of the word throughout time on Mars. Is that a possibility? I actually believe not. All the right building blocks, initial conditions, the same that we think persisted in early Earth, must have been at Mars. So, the tale of two planets. Where do they diverge?
It is this that drives the international space community to take aim at Mars. Over the past 30 years, dozens of unmanned missions have been launched. But the Red Planet has become something of a Bermuda Triangle, with roughly 2/3 of all missions ending in failure. Given the danger and high ticket price, plans for a manned mission have been delayed for decades. For Dr. Bob Zubrin, it's a dream that he refuses to let go.
NASA had plans to send people to Mars by 1981. Those plans were credible. We should have been on Mars a quarter century ago.
Bob Zubrin is president of the Mars Society, a coalition of scientists from all walks of the international space community. The Society has been lobbying Congress, NASA, and the government for years, determined to keep Mars exploration on the radar screen. And Zubrin has been practicing. The Mars Society has set up Mars analog habitation modules in the deserts of Utah and the remote landscape of Devon Island in Canada.
What we're doing at these stations are really what someone would call operations research. We're trying to find out what field tactics and techniques would be most usefully applied on Mars, what technologies would be most useful to the crew.
And Zubrin has more in mind than a quick trip across space. He plans to colonize the planet.
We're going to Mars because Mars is the planet that has on it the resources needed to support life, and therefore potentially someday human civilization.
For Zubrin, Mars is the new frontier.
Whether or not there has been life on Mars, whether or not there is life on Mars, there will be life on Mars. And it will be us.
Zubrin isn't the only one with plans for the Red Planet. Dr. Chris McKay champions another idea, essentially to kickstart the biosphere.
If we go to Mars and find that there is no life, then I say we might as well move in.
And in the case of Mars, that begins with warming up the planet.
Well, we know how to warm up planets. We're doing it on Earth.
By introducing preferably non-harmful greenhouse gases into the Martian atmosphere, we could start a chain reaction.
The effect of these gases would be to melt the ice, bring back the atmosphere, and restore Mars to the conditions it was billions of years ago.
Right. But if we're going to live there, we're going to need oxygen. Well, Chris McKay has that covered.
These organisms are known as cyanobacteria. It's a type of algae, a single-cell type of algae, that has a very long history on Earth. These were the organisms that first made the oxygen. And these organisms could do the same thing on Mars. Send them to Mars and ask them to change the world.
Cyanobacteria, the planet changers.
These are the little green men. They're not men, but they are little and they are green.
But wait, what about the pyramids? The supposed signatures of an ancient Martian civilization. What if the guys that built the face are coming back? Mars. Could that enigmatic face in the hills of Cydonia really be a calling card from a lost civilization? Ironically enough, we might pick up a clue at the World Science Fiction Convention in Southern California. No, we're not looking for Martian monument builders. We're here to meet astronomer Phil Plait, a scientist on a mission to provide participants with a healthy dose of science fact. Today, he's taking on the face on Mars.
Just so we're clear on this, it's a rock that looks like a face. And it's not even that good of a face. It looks like he's got, I don't know, Isaac Asimov.
Phil Plait is the creator of Bad Astronomy, a website and book dedicated to debunking what he calls pseudoscience. For him, the solution to this Martian riddle is elementary.
There's a trait called pareidolia, and it is the tendency to see faces in random patterns. And we see this all the time. You can find lots of features on Earth. I once saw Lenin in my shower curtain. It was just a water stain in my shower curtain. But man, did it look like Lenin.
Why do humans do this? One possible explanation for seeing faces in random patterns is that it's a survival technique going back to infancy. Unresponsive babies are more likely to be ignored or abandoned. So to make sure he gets mom's attention, a baby will seek out the image of a human face and gurgle adorably. Whatever the reason, Phil Plait thinks we can't always trust the evidence of our own eyes.
Our brains don't like random patterns. They want to find some sort of real pattern in the noise, in the randomness, even if it's not there. And so you can just take a collection of dots and you might see a head, or you might see Jesus in it. But that's just your brain trying to find a pattern desperately in something that is patternless.
If you take a closer look at the Martian terrain, the planet explodes with faces. Face-like patterns, Plait insists, not monuments to ancient civilizations. Richard Hoagland, the leading advocate for the theory of monuments on Mars, has countered this argument for years. He insists his theory is based on more than just a pretty face.
If I had to stake my entire almost 30 years now looking at this, that there was at one time intelligent life on Mars and they built something, I would say the geometry of Cydonia is now trillions to one against it being chance, and in any man's or woman's science, when you have that level of odds in your favor, you can say with relatively good backing that it's real.
Fair enough. Let's ask the scientist. NASA scientist Jim Garvin has this to say about geometry.
It is possible to construct geometric patterns between anything. There's an infinite number, in fact, of different affine geometric patterns between this feature and that feature and this feature and that feature. To read one as being the answer to this particular small patch of Mars is extremely challenging to me and to the science community.
But what about those interesting pyramids and tetrahedral-shaped landforms? Just the wind, says Garvin.
If the wind is blowing one way for a while, and the next season it blows this way, and the next season it blows this way, and the next season it blows this way, what happens? Over time, if that's the consistent pattern of the wind, sandblasting, in this case a hill about 10 blocks in scale, you can produce landforms that remind one of pyramids.
Similarly formed natural structures called yardangs are found in the dunes of Egypt's western desert. In short, Dr. Garvin sees the Cydonia region as a natural landscape shaped by the forces of erosion. So what about the face?
When I look at this picture on Mars, I see positive relief landform, a hill of the scale of multiple city blocks, very similar to tens of thousands of others on Mars.
But Dr. Garvin insists you can't prove anything with a two-dimensional snapshot. In order to analyze the structure, he's created a 3D model of the landform by combining topographical data with a high-resolution 2D image. Now he is able to observe the face as if he were flying around it in a helicopter. And from this height, the Sphinx dissolves into landscape. No eyes, no mouth. Remarkable only because this is a hill on another planet.
There's a lot of different interesting ways to look at this feature. The simplest way is the natural way. And that's always worked well in science.
Just one more thing. Why doesn't NASA send one of its robots to take a look? Well, considering the enormous cost and the physical challenges of dropping a priceless asset such as a Mars rover, the target must surely be chosen with careful consideration on the basis of scientific priorities.
Why would we consider this a first priority? And that's the question I leave you with. We're looking for our origins in the history of life in the universe. And there is no evidence that that has a bearing on that question today.
In the end, it's up to you to believe in the magic of ancient monuments or the world of modern science. So Mars. For centuries, the red planet has kept us guessing. First, it was home to an advanced civilization and the Martian invaders of our silver screen. Then, it was a cold, dry, barren planet. And now, it offers the possibility of life, with mysterious clues in a Martian meteorite and the suggestion of water once thought long gone. But is there life on Mars?
I think odds are we won't find life. There's no evidence, so I'm not going to bet my house either way.
But the desire to know drives us ever closer to an answer that may also hold the key to our very place in the universe.
We live in space as small, minuscule amounts of the matter that is the bigger space. The more we understand the history of life in this solar system, in this universe, the more we understand our own life and our own destiny.
It's been 30 years since a human last set foot on another world. If space exploration is to become a reality, not of the past, but our future, perhaps it's time to set our sights on Mars.
There's some moments in history where you have the capability of doing something important, and I think that this generation has the capability of finding out whether we're alone or not.
Either way, it's something we need to know.
If we search the universe and we find no evidence of life, we should start taking seriously the possibility that life on Earth is unique, really unique, and that in a very real way, the contribution of Earth to the rest of the galaxy, to the rest of the universe, may be life itself.
Alone in the vastness of space, perhaps even the worst of our Martian nightmares is better than galactic solitude. One thing is certain. Our best hope for finding out if life exists in the universe lies on our sister planet, the Red Planet, the remarkable neighbor we call Mars.